The next speech of the event is by Elina Saarivuori from VTT, who works at VTT as an expert and project manager in research and customer projects that involve LCA, carbon and water footprinting, and also corporate sustainability reporting. Elina will today address and highlight the basics of water footprinting, what it is, why it's used, and why is it important. So Elina, floor is yours.
Thank you for the introduction and hello to everyone. So water footprint is an emerging topic, and the purpose of my presentation today is to give a general overview of water footprint and what it is about. So what is water footprint? Water footprint evaluates the impacts of water use based on value chain approach. So it is not just an inventory of water volumes that are used, but it's really about the impact. And it includes all water-related impacts from resource availability to pollution impacts such as eutrophication, acidification, or toxic effects. And the ultimate goal of water footprint is to enhance water resource sustainability. And then why water footprint? Well, the scarcity of global water sources has become a major global issue alongside with climate change. And from the point of view from the Nordic countries, water shortages are not very common. And so the water footprint and water scarcity might seem very irrelevant, but the water scarcity is a regional problem, and majority of the freshwater withdrawals take place in watersheds already experiencing high water scarcity. Water is not only scarce in volume, it is also becoming less suitable for productive purposes, and the access to water is being contested more. Concern of the water resources and water quality have led to companies changing the way they address water. The companies are investing in efficient technologies. They are introducing cleaner products. They are reporting more on water. And from the water footprint point of view, good water resources, low water use in the process, and high water purification technologies bring benefits to the product manufacturers. In the big picture, water use as such is not an issue because the hydrological cycle is a closed loop. So what goes up and evaporates will eventually come down. So the water doesn't disappear anywhere, but it can be made unavailable locally. So one should really look at the local impacts of water use. As water is such a topical issue currently, different approaches to water footprinting have emerged during the past years. There are different kind of methods and tools and standards, initiatives, guidelines that have been launched to help calculate water footprint or assess risk, assess the level of risk, assess the level of water management in companies, or demonstrate environmental performance of products. I don't have everything on my slide what is going on in the field, but here are some main topics. So the first box has two main approaches to water footprint calculation: the water footprint network and life cycle assessment approaches. And they both approach the water footprint from different methodological angles. I have more of those methods in my next slide. And the second box has examples of tools that look at water at organizational level: the World Business Council's Global Water Tool and the GEMI local water tool. And the World Business Council's tool maps water use and assess risks relative to to the operations and supply chains of a company. And the EcoWater tool is also made for corporate water management planning. Both tools are online tools. And then the third box I have, the first thing is the ISO water footprint that is being developed currently. And in addition to that, there are also some certification programs being developed or already in practice. The Alliance for Water Stewardship, the AWS, is developing a global stewardship standard which will set out principles for companies for responsible water use. And it will also include third-party verification for companies. And the European Water Stewardship Standard is similar to the global one with a European perspective. And here, more about these methods that address calculating water footprint. This slide shows the most advanced and most used methods. The first one is water footprint networks method. That was the first one that was launched, and it's widely used. It is well suited for calculating water footprints, for example, at national level, and well suited for calculating volumetric consumption of water. But it has been problematic at product level calculations. For example, the Finnish forest industry has tested this method, and they have concluded that there are some problems when you come to product level. Water Footprint Network has also launched these terms green, blue, and grey water, and especially the grey water may be confusing because it is defined as the volume of water use that is needed to dilute your pollutants or the emissions to the level that they are harmless. And in practice, this is quite difficult to calculate, and very often the grey water footprint is actually left out from the footprint calculations. And then you have the life cycle assessment method, which is well settled method and to quantify environmental impacts. And in life cycle assessment, the impacts from pollutant emissions are well characterized, but the impacts from water unavailability are not yet fully quantified. And this is what actually the water footprint is a lot about. But the method development is very active, and different methods have been proposed that range from simple inventories to very complicated and complex impact assessments. So when you calculate water footprint with these two different methods, you cannot compare the results. So a common approach is needed. And luckily there is the International Standardization Organization is currently drafting a standard to give guidelines for water footprint calculation. The standardization was found important because the existing methods are not suitable or difficult to apply at product level. Some technical issues are still being settled in the ISO standard development, but what can be said is that the standard will be based on life cycle assessment. It will include quantity of water use and changes in quality, and the footprint results will be regionalized, so the local water situation will be taken into account, and all impacts related to water will be included. And the purpose of this slide is to show how water impact is generated. So you have two different kinds of water use. You can have consumptive use or degradative use. And the consumptive use, the water becomes unavailable for use in the same watershed, which means that the water either evaporates or it is integrated into a product, or it is released into another watershed or released to the sea. And then you have the degradative use, where the quality of the water is changed and the water can become too contaminated to be used for a specific function. And this leads to loss of water functionality, which generates an environmental impact. And the environmental impact depends on the local conditions, such as the local water scarcity, or the type of water course that is used, or water quality, or time of withdrawal. Here in this picture you have again these different water uses. There's a process that takes water in and then releases the effluent back to the watershed. And here, if the quality is changed, then you have the degradative use of water. And within the process, some water may be evaporated or integrated into products, and this part is your consumptive water use. Now the simplest way to calculate water footprint would be water scarcity footprint, which only takes into account the water quantity that is used. And the minimum data necessary to accomplish this water scarcity footprint would be to find out the volumes, the input volume and output volume of your water use, to come up with the consumptive use. And then you would need the geographical location of the water use. And then you would do the impact assessment, where the consumptive use of water will be multiplied with the local water indicator. I will talk about that more in my next slide. And of course, the impacts of water quality on water availability can also be taken into account, and there are already suitable methods for that as well. And indeed, quality is an important factor in addition to the quantity, because impact of using low water is versus high water quality, the impact is different. And here about those local indicators, they are factors that are used in assessing impact of water consumption. These factors are also called stress indices, and they reflect the competition between users at the geographical site in question. Now, there are different authors that have created stress indices with different background information. Here, what I have on my slide is Stephen Pfister's indicators that are provided in the internet. The Google Earth map provides these water stress indices that range from 0, which means no water stress, it's blue colored in the map, to 1, which means extreme water stress, it's red colored in the map. And when you are online, you can zoom into the map and you start seeing numbers that are those scarcity indexes that are differentiated in many watersheds in the globe to facilitate the calculation of water footprint. And on the right side, you can see examples of different local scarcity indices in different cities in the world. And right away you can see if you calculate your water consumption with the Berlin index compared to the Cairo index, and you can easily see that in Cairo the water impact would be much larger. There are challenges as well. When you calculate your water footprint of a product, different water uses within the supply chain will be summed up. And to do that, you would need to find out the water consumption and the geographical locations of all your suppliers and their suppliers. And this data might not always be easily available. And if you happen to get this data, it might be in the wrong format or in wrong units. If primary data is not available, you can always use generic data from different kind of databases. But also the data banks mostly contain limited information about water usage. They are developing, but still there are some lack of data. The ISO approach offers different options of water footprint assessment. The most simplest one is just to calculate one aspect of water impact, like the water availability. And then you can do a water footprint profile, which will include the impact on water availability, but also other impacts on water, such as eutrophication, acidification, water availability, or toxic effects. Or you can, perform the whole life cycle assessment, which will include your water availability footprint and all the other impacts to water, but also other environmental impacts too that are not related to water, such as climate change. What can water footprint do for companies? It can assist in assessing magnitude of water-related impacts. It can identify opportunities to reduce impacts at various stages in the life cycle. It can help finding hotspots in your value chain. And it can help in facilitating water efficiency and optimization of water management, which can result in savings. It can help you understand your water risks and local status of water resource. And also meeting with stakeholder expectations and help to demonstrate and communicate commitment for sustainable water use. The starting point in my presentation has been a water footprint, and in my last slide I want to show how does water footprint fit into the picture of a company developing a water strategy. So the first step in developing the strategy would be to a company to improve awareness and ask the question, where are we? The company should assess water situation locally and see what are the limitations of the local watershed, and measure water use and efficiency. And then the second step is to find out what are our impacts, and here is the water footprint that can help in it. You would have your whole value chain also evaluated in it. And the interest in water footprint leads to determining the risks that company might and probably will face in its operations. The water-related risks could be related to scarcity or pollution. They could be related to suppliers' risks, impacts on ecosystem. They could be regulatory or reputational risks. And there will be a presentation coming up about the water-related risks still at the seminar. And with the information from the previous steps, the company can implement response. There's more information that maybe could help in improving efficiency. The company can work more with suppliers and encourage them to be more water efficient. And based on the risk assessment, the company could act to mitigate risks and impacts. There are tools to proactively communicate about the water issues. And last but not least, the company should go beyond the fence lines. So not just look at the own side, but go beyond, and which leads to the water stewardship, where a company could engage in partnerships within the water basin. And companies really should, because they are part of the system. Okay, that was my presentation. Thank you very much.
Thank you, Elina. It's a good approach how to integrate the water footprinting as a part of a, let's say, water strategy process or in a part of like a business strategy for a company.